Welcome to this 16th day of Advent of Cyber 2023. Machine learning can't capture this machine. It's a red, which means it's going to be red team or offensive side of things, which is cool. We're going to leverage once again machine learning, and from the name of it, it's going to be helping us going or bypassing something with a captcha. Complex neural network structures. How does convolutional neural networks function? Using neural networks for optical character recognition and integrating neural networks into red team tooling. There will be a VM that I started, and this one will be running. In today's task, we will be looking into the convolutional neural networks, or CNN. CNN are basically structures that allows to extract features that can then be used to train neural networks. In the previous task we used the garbage in, garbage out principle and verified the different mails that were entered and therefore decide if it's a spam or a ham. And we cleaned the stuff, but what we had to provide the labels ourselves. But here, the idea would be to make sure that the neural network can actually verify itself which are the features that it needs to extract in order to identify the best threats, the best things that it needs to take care of or need to keep attention on. We can divide our CNN in three components: the feature extraction, the fully connected layers, and the classification. We have already covered the two last ones because we had worked with neural network structure, and so we are normally familiar with that. However, the first one is the most interesting one because it's going to be taking an image, which is going to be the captcha, and we are going to try to recognize numbers out of it. So first, the idea is to uh, reassess what is an image. The image it's actually an array. It has RGB or grayscales. So if it's RGB, it has like different channels that are leveraged in order to do that. So we'll have to use 4 channels: red, green, blue, and alpha. If it's a grayscale, then it's different because we will have only one, or can consider the alpha one, but that's only going to be using one channel. So it's going to be one 2D array. So if you look at the animation here, you have a way for discrete, basically making sure that we are pixelating the image into something that is going to be recognized or easily readable into a 2D array. And because our network is only interested into numbers, as we did for the text, we are converting that image, which has more information, more data, into something that has less data, but that we can work with. So now that we know how to represent an image, what is the convolution by itself? The convolution step is the CNN feature extraction, and it's actually trying to reduce the size of the array, because even though that one is not that big, we can have like super big images. And so the convolution itself is trying to create a matrix out of another matrix. So here, for example, we are parsing the inside or child matrix into a smaller 2D array, and that's what the different function the different like parsing is going for. We're swooping through the biggest matrix and creating a smaller one, which is going to be representative of the one. So it's kind of like, okay, the average color of that area of 3 is that number, and you are probably sure that you won't be able to, at least you are able to keep the most important value or information out of this without saving a lot of data. So it helps summarize the image in a better way. Of course, the function that is used to um, aggregate or summarize that one is to the choosing, and most of the time part of the interesting algorithm or the way each algorithm or proprietary function is working. As mentioned before, we can create a neural network that takes each pixel as input, but this will be incredibly large network without improved accuracy. So that's why using the CNN, it's helping summarizing, not saving a lot of data, and helps calculating features more easily. There's another step taken by the CNNs, which is the pooling, and it's also another process of the feature extraction. And it helps summarize the data used by using statistical method. And so here you have an 4 by 4, and it's actually straight done into a 2 by 2. In this example, it's taking max pooling and it's finding the maximum value in the pixels and could then use the different statistics. We can also use a statistic, a different one like the average one, and that would be calculating the average of each kernel matrix here. So as depending on how the one is performing, you can use one versus the other or a mix of those. Uh, the last part is sorry, the second step for the second part component is the fully connected layers. That's where we are inputting our different values that we have pulled out the images, and then the classification, which is kind of what we did so in the previous lab. So now that the basics are covered, how can we leverage that to crack the CAPTCHA? So what's interesting here is that all the steps that we will be looking at here right now have already been done by the lab, and therefore we just need to understand what's happening and just leverage that. The next steps will be performed in the hosting model section. However, understanding how training works is an important aspect. So the idea here is that we gather captchas so we can create labeled data, and we are doing supervised learning with the captcha and that will be labeled that way. And then we can train our captcha cracking CNN and verify the accuracy so that we can leverage that into our code. The 1, 2, 3, 4 is basically a loop where we improve accuracy so that until we have a pretty good accuracy. And so here you can see that they have been already done the work, and they have like a temp data that is like full of the captcha, and then we have here a TensorFlow and AOSCR already installed in the Docker container. That Docker will be executing the training data gathering in the browser. We see the authentication page. So gathering training data in order to train the CAPTCHA cracking CNN, they have to create a data set to be used for training. So the authentication page we want to crack is basically this one. So what it means is that you will the process of gathering this data would be curling this page, and then you would have the base 64 encoding version of the captcha image needed. The script did will write the script to basically pull that image and download it to store it in the training datasets. So that has already been done, and the stored data is already there. Cool. Going to look at it right now. The training dataset is then we need to create dataset in the format that AOCR can use. It requires us to create simple text file that lists the path for each CAPTCHA and the correct answer. A script that was used to create this text file can be found under labeling directory. You can use the following command to view the text file that was created. Okay. Training and testing, CD labels, AOCR, train data, blah, blah, blah. Okay. As the CNN has already been trained for you, you can now test the CNN by running AOCR testing TensorFlow records. Testing will now begin. Once a couple of testing steps are complete, you can now stop it once again using Ctrl C. Okay. As you can see from the testing time, running a simple image sample through the CNN is significantly faster than training it on the entire dataset. This is one of the true advantages of neural networks. Once training has been completed, the network is usually quick to provide a prediction. As we can see from the prediction provided at the end of the lines, one of the CAPTCHA prediction was completely correct, whereas another was a prediction error mistaking a 5 for a 6. If you compare the loss perplexity values of the two samples, you will see that the CNN is uncertain about its answer. We can use this as to our advantage when performing live prediction. We can create a discrepancy between CAPTCHA prediction accuracy and CAPTCHA submission accuracy simply by not submitting the CAPTCHA that we are too uncertain about. Instead, we can request a new CAPTCHA. This enables us to change the AppSec of our attack, as the logs won't show a significant amount of entries for incorrect CAPTCHA submission. We could even take this step further and save the CAPTCHA images that were incorrect on submission, so we can then label them manually and retrain our CNN to improve the accuracy. So having the step 1, 2, 3, 4 from earlier as a loop and being able to make our model even better. Now, since everything is trained on the VM itself, we need to host the CNN to send it CAPTCHA through our brute forcing script. For this, we will use TensorFlow serving. Once a convolutional neural network has been trained, we can export the weights on of the different nodes, and that's why it's super easy to deploy. We now export that model from the Docker container using the following command. Once that's completed, you can exit the Docker container terminal, use the exit command, and kill it. TensorFlow serving will run in Docker container. This container will then expose an API that you can use to interface with the hosted model to send it a CAPTCHA for prediction. You can start the serving container with the following command. This will start a new hosting OCR model that was exported from the AOCR training Docker container. We can connect to the model through the API hosted on now we're ready to help Max Kitty regain access to the HQ admin portal. So we have been provided with the custom script that we will use. You can find the custom script and password list on the desktop in the brute forcer folder. So it's a request base64 JSON beautiful soup. So we'll be reading HTML, encoding stuff, and doing HTTP request. The idea would be so do we have our Docker container running? Nothing is running, so I need to run that one. Okay, we have it. Perfect. If I do a curl, Okay, weird. Oof. Okay, looks like we can't find models. I will kill that one. Okay, so do I have that thing? Okay, so I need. Hmm. Do I need to be root? Okay, so actually there was a Docker container that is already created for us, so that's where we actually need to connect to Docker exec that ID bin bash. And now if I do OCR, yes, it's there. Okay, so we have stuff. Cool. So if I do that now, modify to the temp dir. Okay, looks like it worked. Now it's asking me to exit and kill it. Docker kill that one. Poof. And now I can run that one. Okay, looks like it's working this time. So if I now do a curl, I have something awesome. So we can work on that now. This one I don't care. Give me my Poof. So now looking back to the brute forcer PI, the username is admin and the password is part of the list of password that we have here. So URL for our request is that one or that one for the model. We load the password text for brute forcing. We'll open it as a read mode and take each password in one line. We set a flag as false, a counter, and as long as the access is not granted and we still have password to check, we are setting the current password to the indexed password and open the website, parse the HTML, find the image, take the source of the encoded image, pull that, create a JSON request for it, and ask our model what will be the number for it. If the accuracy is below the 90%, we are not feeling lucky and continuing without testing the password. Otherwise, we are posting the username, the current password, the answer for the CAPTCHA that is provided by the model, which is prediction outputs output, and submitting the button and posting it. Then if the response is incorrect CAPTCHA supplied, we know that it's the incorrect password, and then we carry on the loop. Otherwise, if it's the wrong password, that means we had the correct CAPTCHA, so we move on to the next password, and otherwise the access has been granted. Yay, awesome. We flag true and we stop. Let's type blah blah blah. That's exactly what I explained. And now if we run that one, so I'm back to the brute forcer and checking if it works. Really not going to guess that. Sorry. Awesome. So we saw how CAPTCHA can be leveraged for red team. So answering the question now, what key process of training a neural network is taken care of by using a CNN? Feature extraction. Yes. What is the name of the process used in the CNN to extract the features? Convolution. And the name of the process used to reduce the features down, it's the pooling. What off-the-shelf CNN did we use to train a CAPTCHA cracking OCR model? We used Tesseract OCR. No. What CNN we used off-the-shelf? Oh yeah, it's the AOCR. Attention OCR. Attention OCR. What is the password that MacReady set for on the HQ whatever? We had this one and probably going to admin 82 88 9. Sign in. Don't save. And the CAPTCHA is CAPTCHA can't hold me back. There we go. Yay! If you enjoyed this room, check out our red teaming learning path, which has a lot of additional stuff. Thanks for your time. Take care. See you next day.